Let me use the same. A is equal to 20. Again, after this, at this simulation time, I am going to stop. So how this will work? It will execute this, then it will stop the simulation. What user can do is nothing but he can debugging the output. Okay, let me run, then you will be understanding. So to show this dollar symbol stop operation, let me run this program in the models. Okay, so there I can stop the simulation. Then by running the command again, rest of the program I can compile. So for this, let us create the folder here. I'm going to copy this in the file. So what is the extension I can give to this file? So let me take this as file dot v. That what is the save type I need to change? All type. Then only it will saving this as dot v extension. If you use text format, that will be saved as what? Text file. Correct? You can see this my new folder. Now I'm saving this file extension with what? Verilog. Now I need to write the run.do file. So what is the run.do file I need to write? Will it work? Right? Well, Verilog file dot v file name, then visit the test bench module name db. Then if I need a wave, I'm going to add the wave. If I don't need a wave, then I can use the run item. Correct. So what extension to this file is? What is the extension of this do file is? This is run dot do. What I need to change this as alt. Now this will be saved as a what? Do file. Run dot do file. Correct. Now I want to compile this program. How to compile in the model sim is? I can open the model sim. Okay, one way to open the model sim is nothing but here only. So one usual way, you know that you are copying this address, you are opening the model sim, then you are using cd command, change the directory, then putting in the flower brackets and then changing the directory. Then you are executing command called do. For do what file? Run.do file. You are doing the run.do file. See, another way to execute this file, compiling this file, right click, go to the opening terminal. So now I'm launching my model sim through the shell. What shell is nothing but PowerShell, Windows PowerShell. This is by typing what command is model sim. Model sim. Okay. Then I'm giving the flag is do. What I want to do is nothing but do run dot. This one I want to. In my run.do file, I have all the comments. Correct. First, it is going to compilation, elaboration, and simulation comments I am putting in my run.do file. Correct. Now I am going to launch the models. Did you understand? So now I am launching the models in. Now it is executing the program. So you can find all the errors here. Now it is printing. So the model symbol, it is, see, in this my program, I am using what? A is equal to 5. This is printing, but I am using what here at /10 is. I am stopping my simulation. It is not printing A is equal to 20 here. This is how this dollar symbol stop will work. Now it is printing what? A is equal to 5. Now I want to debug this. Now I can debug this program. Since I am using dollar symbol stop, the simulation stop after execution of what? A is equal to 5. Now remaining program I want to execute. What I want to do is just to type run. Then it is going to print what? A is equal to 20. So what is the purpose of this dollar symbol stop is used for what? Halt the simulation. Halt the simulation. Why you are halting the simulation? To debugging the outputs. See, here I am using only one variable with a different value. Imagine you are doing big program. There ports are 10 ports are there, 20 ports are there. So debugging became very complex when you are displaying at one stretch. If you are displaying all the signals, Now what you can do, you can use the dollar symbol stop to debugging first signal, debugging second signal, debugging third signal. So for debugging purpose, you can use what? Dollar symbol stop. Did you understand this task concept? This is related to what? Simulation related. What is the use of this dollar symbol stop is nothing but stopping the simulation. What is the use of this dollar symbol finish? The dollar symbol finish is used to terminating of my simulation, where you want to stop the simulation. You can use this dollar symbol finish. So this dollar symbol finish task terminates the simulation. Are you understand? So this is relating to what is task function these are. What task these are? What related task it is? It is simulation related. Dollar symbol stop is used to what? Stop the simulation. Dollar symbol finish used to termination of the simulation. Did you understand this? Dollar symbol stop and dollar symbol finish. So you can see this is the example here. What this example will do? I'm using initial begin. Before that module name, everything will be there. Declaration, data type declaration with the variables. Okay, initial begin. Clock is equal to 0, clock is equal to wait. Then we are stopping at what time? Ready time. Correct? So 100 time I'm stopping. This will suspend the simulation at time is equal to 100. Again, to continue this, what command I should do in my model sim? Run. If you press run again, it will continue. It will finish at what time? It is going to finish at the 900. Did you understand? So if you see your model sim, we are stopping at what time? So this is not printing the time here. Yeah, it is printing the time. So time it is printing at what? It is equal to 10 picoseconds. The precision for this model sim is nothing but it measures in terms of picoseconds. Okay, again this will be, time will be for this is nothing but 20 picoseconds. Did you understand? So these are used for dollar symbol stop and dollar symbol finish are using for stop the simulation and termination of the simulation. So these are commonly used some of the task functions when you are working with your test benches, correct? And upcoming sessions subsequently we will see that what other task functions are there. I mentioned yesterday that there are many task functions on there. So wherever it is necessary, we will start using the task system task functions. Did you understand? Now let us go with the idea about what is a compiler directives. What is the use of this compiler directives is, in Verilog, compiler directives are provided in the Verilog. It is compiler directives like, if you remember the C programming, if you understand the C programming, how are you including your .h files, header files? Hash include followed by what? .h, math.h, ponyo.h, string.h. Header files, to include the header files using hash include. Here, similarly to include the files, you are using what? Compiler directives. What are the compiler directives you are using is tick define, tick include. So if you remember when you are running a program in model sim, you are writing design file in the different file with the .v extension and test bench in the what? Different file. But in the very first line of your test bench, you are included with what? Your design file. Using what? Using compiler directives. So this compiler directives are defined by using, beginning with a tick. Tick followed by what? Keyword. Dollar symbol followed by the keyword is nothing but what? Dollar symbol followed by the keyword is system task function. Tick followed by the keyword means what? Compiler directives. You are using compiler directives in your test bench, right? Very first line you are using tick include followed by double quotes file name.v extension. Correct. What is the meaning of that? What is the use of that compiler directive is? It is going to including your design file into your test bench file. Are you understand? Like in C program, you are using hash include to include the header files. Here you are using what? Tick. But in Verilog, hash is a different meaning, right? If you compare with the C programming, what is the use of hash in the Verilog? It is going to use to representing the simulation time, sim time. Correct. The meaning of C will changes. Hash. Hash is used to including the header files. Here, to include the header files, you should start what? Tick include. Like few more compiler directives, we have a tick define. What do you use tick define? So tick define is used to one-time constant include. Like in C programming also hash define. Here it is what? Tick define. So you are going to creating a text macros. One-time inclusion. That can be used inside your program. So that you can customize your program by changing your tick defined macro, text macro. So we'll take one example and we'll see. Okay. So before that, we'll understand the use of this compiler directives. So all compiler directives are defined using what keyword? Tick followed by the keyword construct. The two most powerful compiler directives which we widely used in Verilog is nothing but tick include and tick define. So tick include already you are using for including the files, Verilog files. Correct. So tick define directives. Now let us see what is tick define. The tick define directives used to define the text macros in the Verilog. Text macros in the Verilog. So let us take one example to this. Then we'll coming back to this tick define. Tick define. Okay. So I'm going to write simple program to this. So I'm going to using tick define. Tick define. This will define inside the module or outside the module. Outside the module. Outside the scope of the module. Okay, tick define. So let me make a step. I'm using a macro. This we call it as a text macro. Depth I'm using the name of this tick define. Like it is quite similar to your parameter. So what is the use of parameter? Yesterday we spoke about the parameter used to define the constants, right? Define the constants. So if I want to customize my program, I can change only the parameter so that I can customize. If I want to change the width of my port, correct? I'm using parameter. Parameter followed by parameter name. Then I'm assigning the constant value. So here this tick define is also kind of same thing, but this tick define will be defined before the module start. Then this will be start with the tick followed by define is nothing but compiler directives. I'm using depth. So this is a text macro I'm creating. The macro name I'm using as a text format, right? So that I can call this is nothing but text macro. So let me make this as let some constant value. I'm defining text. I'm defining depth is equal to 8. Now I'm going to, let me use this inside here. So let us take the range. The range, instead of 7 down to 0, so what I can do is nothing but I'm going to use this tick depth minus 1. Let me make this as clear. Then I'm going to assigning the value of 8. Now, according to this program, what is my depth is 8. So 8 minus 1 is nothing but what? 7 down to 0 means A will take vector of what? Width of 8. Now I need to assign the value of 8. Let us assign the value of 8. Let us assign 8 tick B or binary, correct? Or I can assign the hexadecimal, correct? 2 tick H. Let us assign AB. A will take how many bits? 4 bits. B will take 4 bits. Let me print this value. $symbol display. $symbol display of. So A is equal to percentage B. 0B. Let us pass the argument E. So what output it is going to give me? What output? Now A is a vector, right? Vector whose width is nothing but what? 8. So now I'm assigning a hexadecimal value to the what? A. Each hexadecimal value will represent 4-bit binary. Now it is assigning like B is nothing but 1011. And from the LSB it is printing at 1101. A is nothing but 0101. So this output I'm going to get. So line number 3. So I have an error, invalid module item, syntax error, invalid module item. So I am using tick define here. Let us debug this program. I'm assigning this. Okay, let us assigning the depth is 8. I'm using this depth. Spelling correct. Let us check the constant is truncating the 2 bits. Is taking extra digit given for the hexadecimal constant. Okay, once again. So before using this, let us make this into 7 and check. And then I will be understanding that whether I have a problem with the tick define. Now A is a 8 bits. I am assigning 8 bit. Why I am getting warning error? The size XR. What is the size I should keep to assigning this value to the rich? Is it 8 tick or 2 tick? 8 tick. The size will indicate what? Bits, right? Yeah. Now it will eliminate the error. Now size will indicate the what? Bits in terms of bits, right? 8 bits. Now let us use this tick define. Tick define, I'm using the text macro is depth. Let me use this depth here. Tick depth. Let us use -1. So on the line number 4, I'm getting error. This should be declared as tick define depth. Okay, let me see the syntax to this. I should use, yeah. So the one mistake I have done is, so tick define text macro without the end with the semicolon. Correct, header files. Hash include also you are not giving colon, right? So before the module scope, if you are defined, that should not terminate with the what? Colon. So now I am getting the output. So the mistake I was done earlier case is nothing, but I was using depth is equal to 8. Then I end with the semicolon. So now I am using tick define here. Now what is the size it is taking? My A is nothing but 10. 8. Now if I am making this into what? 16. So I can easily customize my program. Correct, by using what? Tick define. This is how the tick define is using to keeping the constant using the text macro. Okay. Or I can use this tick define to set the flag or set the flag or deset the flag, means removing the flag. So for these cases, I can go with the compiler directive is nothing but tick define. Now in this case, what is the output I'm going to get? Since I'm using size 8, I should use what? Size 16. Correct? Size 16. What output I'm going to get? It is a 15 width, but the register, now register size is nothing but 1. The A is 16 minus 1 is 15. But I'm assigning what? Only AB value. So let us remove this and print the width it is. Now width is nothing but what? Width of A is 16. You can understand. If I'm using 0B, it is going to what? Truncates. I mean, removes this 0 value. Now, if I'm going to make this is, okay, let us assign the decimal value like 25. Now, I want to change the width of this range to the 32 bit. What changes I want to do in my program? I want to make this A to 32 bits, width of 32. What changes I want to do here? I can define the what? 32. So that now it becomes what? My register of 32. You can see my register of 32. Now you can define the macros, text macros here. You can use that inside your program to customize. Correct. Somewhere you want to change the port to 16 to 32 or 30 to 64. So you are using register many times. There are 10 times in your program. Each time you can't go with each line and changing the value. Correct. Changing the value. In such case, what you can do? You can define that as a text macro. If you are using this text macro, you should start with what? Tick depth. Don't forget this. So this is a tick. What is this is depth here? It is nothing but I have a macro. I have created the macro. What is that macro name is nothing but a. So what macro this indicates is nothing. This is a text macro. Are you understand? So one compiler directives you are already studied. That is tick include. Is used to include the design file, which you are widely using when you are writing a design file and include it in the test benches. Another one is nothing but tick define. And then another two more are there. So we will discuss that in the upcoming sessions, like a tick if def. That is for compiler conditional compilation and conditional execution. You are setting the plan, what portion of the code will be you need to execute. So other compiler diagrams which we widely discuss later. We'll discuss now which is most commonly used in our programs. Tick define and tick include. So tick define directive is used to define the what? Text macros in the Verilog. This is similar to the as defined constant in your C program. So I'm defining the constant on depth is equal to 8 I'm making. Or depth is equal to 16. Depth is equal to 32. So the defined constant or text macros are used in Verilog code by pretending them with what? By pretending them with what? Tick define. You can see in this program, I'm defining the macro here. I'm using in my Verilog programming, or I'm pretending this depth means text macro here is. Start with the tick depth. Are you understand? So the Verilog compiler substitute the text of the macro whenever it encounters what? Tick macro name. So here what it encounters in this program? Whenever it encounters this depth, tick depth, what it encounters? It encounters as a 32. So for this kind of operations in Verilog, you can go with what? Tick define. Did you understand this? This is a tick define. So this is an example you can see the tick define directives. Define a text macro that defines a default word size. How to write this? Default word size is I can use tick define. I'm using the macro, text macro. Word underscore size is my what? Text macro name. And what is the word size is talking about? 32. So this is nothing but 32. And define an alias. Look at what is meant by alias? Short notation of the longer notation, right? So that we call alias. Alias in name is what? Alternate name, means shorter notation of the name. So instead of using dollar symbol stop, I can make this as what? Alias. You can see tick define. I'm using the text macro as dollar symbol star. What is meaning of this is tick define now? Instead of using in my program dollar symbol star, I can use what? Yes, tick is. I'm making the stop as a dollar symbol stop system task function as an alias. I'm aliasing this into what? Yes. Did you understand? So what is the meaning of this program is? Okay. Let us copy this program itself. Before that, let me copy this program to the text file. Please, second. Second only first installment is second installment we have to complete before now. Please complete. Please start do the payment. Don't delay. Don't compare with your friends. Don't wait until morning. Okay. Now got it and going to begin. Last month the enrollment you have to pay, but no one will complete. And any concern, please come to us. Okay, let us take an example. We are analyzing for what? Stop rate. Yes. And this will be analyzing to what? Dollar symbol stop. What is dollar symbol stop? System task function which is using for simulation, for stop the simulation, for debugging purpose. Correct. So this I am analyzing to what? Yes. Wherever I can use a dollar symbol, dollar symbol stop, what I can use here? Yes. Is it yes or tick yes? Okay. That micro, you should interpret this inside your program with what? Start with as a tick yes. Correct. Here also I can write what? Tick yes. Tick yes. Now what is the meaning, literally meaning of this? What we have done based in this program is, we are analyzing. What we are analyzing? The dollar symbol stop is analyzing to what? Yes. How I done it is nothing but using tick define. In earlier program, I was making a text macro with the width constant value. So this another example is what I'm making as the alias. Correct. So instead of using the dollar symbol stop, I can use what? Tick capital S. So this is the example I was talking about. Define an alias, a stop, dollar symbol stop will be substituted whenever what? Tick S appears. How you can define this? Using tick define. Yes. Then dollar symbol stop. Did you understand? Now coming to this, what is this one? This one, what is the use of this one is? This is tick define word underscore range. Again, range 30 down to 0. So what we are doing in this case is, what is the use of this is nothing but. Okay, let us take this example. So this is creating a macro of what? Word, correct? Underscore, range. If you notice properly, all my text macros I am representing what? Capital. So this is for understanding that these are what? Text macros in your program. Okay, it need not be these capital letters. You can use small letter, but differentiating that these are the text macros I am using in my program, so that I am writing this in what? Capital letters. Now what is this example is? So this is a tick defined word underscore range, and what we are doing is nothing but range of what it is 31 down to 0. So what is the meaning of this is? What is the meaning of this is? Let us declare the range. Range 31 down to 0 of A. 31 down to 0 of A. Correct. This indicates what? The A is a vector of what? 32 bit. So instead of this range 31 down to 0, what you can use? You can use what? This is same as in this one, right? Tick word underscore range of A. This is correct. Are you able to follow me what I am saying? So here I am declaring range 31 down to 0. This complete this I am making what? Macro. What macro I am taking is word underscore range. Now this A is nothing but 1. It is arranged 31 down to 0. Correct? Now let us run this program. Let us print. Okay, I am taking A is equal to 5. Let us print the value of A. So now A should be what? How many bits it is? 32 bit. Correct? I am declaring this as what? As a text macro, word underscore range. It should take the 32 bit. Now this is a range with the 32 bit. I am assigning A is equal to 5. Are you understanding? What is the three uses of this tick define? Tick define is used to making the text macros to keeping the constants. Tick define used to making the aliases. Correct. Tick define also used for I can make the range 31 down to 0 as a text macro. Did you understand? So if I want to make this into the 64 bits in my program, what I want to do? I should just changing my what? This is making the what? 16.3. So that my A will be what? 64 register size. Correct? You can see this is 64 register size. Or understand what is the purpose of the tick define? So these are the uses of the tick define. So if you are using the macro inside the program, you should interpret it that with what? Tick. Correct? If I'm not using this tick here, I'm not interpreting with the tick here, what will happen here? Now it is not taking as this a text macro. This is taking as a variable, but it will give the syntax error. Now you can see it will print the syntax error, invalid module instantiation. So that if I'm defining the macro, I should interpret it with the what? Tick. Are you understanding this? So this is regarding about tick define. Tick include and tick define. And other two commonly used other directives which we are using is nothing but tick if define, tick if end define. We'll see this later part of the course. Okay, and then time scale. The time scale is used to executing the simulation with our reference time. For that, we are using time scale. You may see that in some programs are using anyway, tick time scale is equal to 10 nanosecond by 1 nanosecond or 1 nanosecond by 1 nanosecond. Still, you are not including the time scale, right? So we'll see later what is the use of this tick time scale, other directives, compiler directives. As of now, up to now, we start using the tick include and tick define. Correct? So what is the use of tick include? Tick include allows you to the including the entire content of the Verilog source file into the another Verilog file during the compilation. This is what exactly you are doing in your test bench. Correct? You are including your design file into what? Your test bench for compilation, during your compilation. So this works similar to what? Tick include. Tick include will work similar to the hash include in your C programming. So this directives is typically used to include the header files. So which typically contains the global or commonly used definitions in the program. So this is how you are using tick include header.vfile in double quotes. Did you understand? So this is other two directives which we see in the subsequent sessions. So with this knowledge of lexical convention of the Verilog programming, what all discussing up to now, use this knowledge to go with now different level of abstractions, gate level, data flow, behavioral model. Did you understand? You should have this basic idea to write any Verilog programming, any level of abstraction. Okay. Now let us begin with. Okay, we'll take a small break for 5 minutes. After the break, so before going into different level of abstraction, so we'll deeply go with what is module, what is the port list, how you can declare the port list, what are the types of port list we have, how you can declare the port declaration, and the module definition, what you are going to write. We'll see that, then we'll go for level of abstraction. Now you can take a break for 5 minutes. After the break, we'll start with the definition of the module, and then we'll go with the level of abstraction. Okay, let us restart the session. Until now, we talked about the lexical convention of the Verilog programming, right? Okay. So before going to different level of abstraction, so we'll talk about definition about the module. Okay, what is a module? What go inside the module? What are the optionals in the module? How to write a module? And then how you can connect the ports. When you're modeling the hardware, what is meant by port list? What is meant by port declaration? How you can connect the ports? When you're connecting the ports in the test bench, how you can connect port connection by name and order list. We'll see that definition, then we'll go with the different level of abstraction. First, we'll start with the data flow, then we'll go with the gate level. So, if you look at the module, you can see if you look at the module, so what we have in the module? Second, let us close this. Okay. Look at this module and ports. What we have in the module? Module will be start with what? Module name. Correct? And what we have to the module? Port list. And what we have? Port declaration. If the ports are present. If ports are not present, there is no need of port declaration. Correct? And then what do we have? Parameters. We talked about parameter keyword. The parameter keyword is used to define the what? Define the constant to the program that can use inside the program to customizing the program. You can use the parameters. Correct? So this is how, if you look at the complete structure of the module and the ports, first what we have, module name, port list, port declaration, and then parameters. It is optional. If it is required, you will be writing a parameter. If it is not required, you won't write the parameter. And after declaring this module name, port list, and writing the port name, module name, port list, and port declaration, then we have declaration of the wires or registers or other variables. This is also optional. And then after declaring that, in the module definition will goes, what are the level of abstraction is. First level of abstraction is nothing but data. What keyword we are using for the data flow is nothing but one, assign. So there is a continuous assignment statements we call. We'll see more detail about this when you're talking about the data flow. And then, if any lower modules are instantiated, so will be instantiated in the module definition. Instantiation of the lower level of modules. And then, what is this is nothing but always an initial blocks for what? Behavioral model. All behavioral statement will go in these blocks. Which block? Which goes inside the always in the initial block. Then, so we'll be writing a task and functions. Like in other programming, you are writing a functions, right? What is the use of functions in the other programming language? What is a function? What is the use of the function in the other programming language? Function are used to reduce the code size for the reusability of the same code for the multiple times. You are going to write the function and you are calling the functions. In Verilog also, so we have a functions and the task. Did you understand? So that goes here. And then this module will be end with what? End module. End module. Now let us write simple program to this for the module definition. So this module definition will be starting with what? Module name, correct? Module name. Let us write a program for AND-gate in all level of abstraction, and we'll understand what are the port list, what is the port declaration. All these things now we'll understand. Okay. If you talk about in Verilog, module and its ports. Module and its ports. So in Verilog, start with what? Module, correct? By keyword module, followed by what? Module name. So this is a module name. Let us make a AND-gate. Or shall we write for half order or full order? Anyone, it is okay, right? Okay, let us write AND gate. AND gate followed by what? Port list. Now we are declaring the port list in the parentheses. Is it AND gate port list is mandatory? If I'm modeling, I'm writing a Verilog program for AND gate. AND gate is in digital term, it is a hardware. I want to model that using Verilog programming. So that what is the port list on there? The port list of A comma B comma Y. So this we call it as what? Port list. Port list. So this will end with what? Semicolon. Now I'm going to do what? What is next step? This is my module. Module name followed by what? Port list. I'm listing all the ports. If I'm talking about AND gate, my ports are what? A and B and one output. Two input AND gate is two inputs, one output. This port list will be varies for different hardware modules. Correct? If you take a multiplexer, you are reading I0, I1, I2, I3, and then S0 and S1, then Y. Then what is the number of port list are there in multiplexer? Is 4x1 multiplexer. 4 into 2 into 4 plus 2 plus 1. 4 inputs, 2 select line, 1 output. Number of ports are 4 plus 2 is 6, 6 plus 1 is 7 ports. See, here I am writing for AND gate. How many port list? 3. Correct? 2 input and 1 output. Now, after writing the port list, after writing the code list, now what we need to do? We need to declare them. We need to declare them as a whether this port list are the input ports or output ports. Correct. To declare them as an input port, what keyword I can use? Input keyword. Correct. Here, which one is the input port and which one is the output port? A, B are the input port I can take. Or you can take B and Y also input port. Then A became what? Output port. Correct. So this is nothing but the input. A comma B. Correct. Then what are the output is nothing but here. Y is the output. This is declaring as an output Y. So this definition goes like this. Module name, port list, port declaration. So what are the types of ports we have? Input port, output port. Now we can also will have an in-output port. 3 types of the port declaration. One is input port, output port, and then in-output. That will be acting as an input as well as what? Output. In this case, A and B is acting as an input port, Y is acting as an output port. You can understand. This is also fine. Or I can write the module like this also. How I can write the module is module name is AND gate. I can write the port list along with the port list. I can declare the port declaration also. I can write here what? Input A comma B. Then output is Y. This is also fine.